Thank you. I am Hamid Reza Zuhuri, the Director of Product at Edgecortix Inc., and today I'm excited to demo the Dynamic Neural Accelerator-F-Series AI engine alongside with the MERA compiler software toolkit designed for real-time deep neural network inference on FPGA-enabled edge servers. The DNA-F-series are a group of specialized IP based on Edgecortix's Dynamic Neural Accelerator AI processor architecture. It's designed for deep neural network inference on Xilinx MP-SoC and ALVEO FPGAs, optimized for high-resolution streaming data. Today, we will demo the DNA-F200 AI engine that delivers 2.6 TOPS running at 300 MHz on ALVEO U50 FPGA card and can be deployed easily with Docker containerized environments on edge servers. Our software toolkit, the MERA compiler, which supports the Apache TVM frontend, is provided alongside with all DNA-F-series products and enables seamless porting of deep neural network models written in standard machine learning frameworks like PyTorch and TensorFlow Lite. It also has a built-in interpreter and simulator, enabling hardware-less performance evaluation of pre-trained neural network models. This figure shows an example of compiling any pre-trained PyTorch model using the MERA compiler in 3 simple steps. Step 1 involves getting the pre-trained model and applying standard PyTorch quantization and JIT tracing, which is independent of our MERA compiler and DNA. As such, machine learning engineers don't have to worry about the internal details of DNA or the FPGA. In other words, this step only uses standard machine learning tools. In step 2, we specify the input data resolution and pass the quantized model to the MERA API. We also specify the target for deployment, which can be the built-in interpreter, or the simulator, or the actual FPGA hardware. This generates the executable.so files, and finally in step 3, we can directly execute these files on the FPGA device running the DNA-F-series AI engine. The end application calling these files can be written either in Python or C++. Let's now look at a few demos of running DNA-F200 on the ALVEO U50 FPGA. This figure shows an example setting for real-time vision applications with DNA AI engine. High-resolution inputs are provided directly from the camera connected to a host system running the Ubuntu OS. The results of the deep neural network inference are displayed on an external monitor also connected to the host system. The DNA-F200 AI engine is running on the Xilinx ALVEO U50 FPGA connected via PCIe to the host system. The DNA-F100 and F200 AI engines are available as prepackaged Docker containers and can be easily deployed on on-premise edge servers or on FPGAs available on the Nimbix cloud. Now, let's look at 2 applications using this setup. Here, we have a demo of depth estimation using input from a monocular camera. The model used is called MonoDepth with 40 megabytes of model parameters post-quantization, making it a fairly large model which will not fit on the FPGA on-chip memory. Now, let's start the video. As we can see, the model correctly recognizes the distance of different objects from the camera. Far away objects are shown in blue, while nearby objects are shown in yellow. We observe that, despite large inputs and model size, we can get real-time performance without degrading the accuracy. Note that the DNA-F200 AI engine is running at 297 MHz in this case. Since the model here is 40 megabytes in size and does not entirely fit on the FPGA, the MERA compiler efficiently manages data movement between the FPGA external DDR memory and its on-chip memory in order to minimize overhead, which directly results in the real-time performance. Now, let's look at an object recognition demo using a different model within the same setup. Here, we have a typical MobileNet SSD object detection model compiled with the MERA compiler, which is trained to recognize people. The camera is capturing HD resolution images and feeding them in a streaming manner to the FPGA. That is, the order and the sequence of the images is maintained. In this case, all the image processing happens on the FPGA with the DNA-F200 AI engine. Now, let's start the video. As can be seen, DNA enables maintaining the inference latency low, especially under the streaming data conditions. We can observe that even with large megapixel data, in this case HD resolution, we can achieve accurate and low latency object detections. As the model parameter size is 4 megabytes in this case, the MERA compiler can fully utilize the on-chip memory on ALVEO U50. Since DNA-F-series supports diverse neural network operators out of the box, other similar vision applications can be readily deployed using PyTorch or TensorFlow Lite as well. In summary, today we demoed the dynamic neural Accelerator-F-Series AI engines and the MERA compiler, which are currently available for FPGAs, enabling high-performance computer vision applications on its servers. I thank you for your time, and here are a few links you can use to learn more about DNA-F-Series products or evaluate them for your end applications. If you're interested to discuss specific applications, please feel free to reach out to me, Hamid, at edgecortix.com. I'm looking forward to your questions now. Thank you.